Good evening, everyone, and welcome to the third session of DS404. I'm Sharad Jacob, and I'm here to just start off the session. First of all, if you haven't been for the previous sessions, just to illuminate, this is a series of sessions that are based on exploring data structures and algorithms, and DS404 is conducted by both TLE, MEC, and TC. So if you wish, these sessions offer certificates. So if you have just joined this link directly, do find the sign up link, registration link, and sign up officially for the sessions so that you can avail for the same. I would also like to notify for those who have been through our previous two sessions and you want to revise, you want to go through all of it again, the links to the videos are sent in your mails. Yeah, as well as the resources for the same. So you can find as well as answers to the contests that have been held after each session. So with all of that in mind, I would also like to remind you to go ahead and join TLE's Discord server where these resources will be put further. So I think Hannah can put the link to the Discord server and you all can join in right now while Gautam sets up his slides. Yeah, and today for today's session, our topic is stacks, primarily stacks, and Gautam S. Baiju is exploring it in detail. So Gautam, you ready?
Yeah, am I audible?
Yes, you're audible. You can
visible?
present your slides. Yeah.
Okay, so I'll share my screen, just check if it's visible.
Yeah, sure, all right.
Can you see it on the screen now?
Yeah, it's visible, yeah.
Yeah, so good evening, everyone. I'm Gautam. So I'll be taking the DS404 session 3. It'll be on stack. So like before we start, so if you guys are here, just like put something in chat, anything, doesn't matter, if you want. Just to see if people are active. Yeah, okay. Hello. Yeah, okay, that's a lot of people. Nice. Okay, so I think we'll slowly get started. So these are like the topics I'll be covering in this session. So in the beginning, I'll just tell you different types of data structures and what a linear data structure is. That's just just for introduction, nothing too deep into that. Then we'll see what a stack is. Then I'll show you how to implement a stack in C++. We'll be using arrays. And after that, we'll we'll get the theory out of the way first, then we'll do a few questions. And at the end, I'll also tell you about the applications of stack. So first, data structures can like mainly be divided into two, linear and non-linear. And we'll be dealing with stacks, which is a linear data structure. I've shown this picture just for you, just for an idea. I'm not gonna go too deep into this. So linear data structure is a data structure where data is arranged linearly. That means like, suppose you have numbers from 1 to 10. Linearly arranged would mean after 1, 2 would come, then 3, then 4, and so on in a straight line fashion. And when you traverse data in a linear data structure, you can do it in a single run. I'll just show you a figure to make it more clear. This is how a linear data structure would look. This will be like the first element, then the next, then the next, the next, and so on. Whereas, oh wait, is the figure completely visible? Can you put in chat if it's not visible? Okay. So a nonlinear data structure would be less similar to this. There'll be one element here. It will be connected to maybe one or more, and so on. So this is just for an intro, nothing too deep here. So now we'll start with stacks. So by definition, stack is a linear data structure that follows last in, first out principle. So when you say last in, first out principle, think of it this way. It means that the last element to go into the stack will be the first one that comes out. It might not be clear when I say it. I'll show you a figure that'll make it a bit clearer. Before that, we just go through the theory part. There's a pointer called top in stack. This top pointer will point to the topmost element in a stack. Once again, when I show you the implementation, it will be more clear. Then adding data to a stack is called pushing, and removing data from a stack is called popping. Okay, so now I'll show you a figure just to give you a better idea. So for a stack, imagine an empty container like this. This container should only have like one opening on top. Initially, when there's nothing inside, it will be called an empty stack. So think of a data as a box like you see here, a box with one written on it. This is a data element. So adding it onto the stack would mean you take it to the top and you drop it. It will fall straight down onto the bottom. And when you add another one, say another data element 2, you'll bring it to the top and drop it. And now it'll be resting on top of the first data element. That is just like a stack in real life. In real life, say you have a stack of plates, you'd be arranging them on top of each other. And so we can keep adding data to it just like this till we reach the limit of the stack. And if you want to remove an element from the stack, we notice that there's only one opening. So we can only take the topmost element out of this. And this removal of element is called popping. That's what you see here. 3 is the topmost element right now. You can only remove that first. You'll have to pop it out. Then only you'll be able to take 2 and pop it out, then 1 and so on. So I also told you about a pointer called top, right? At all times, this top pointer will be pointing to the topmost element. So here in this case, can you guys comment in this figure, the second figure, can you guys comment where top would be pointing to? If you want. None? Yeah, there's only one element in the stack, which would be 1. Since there's only one element, that will be considered the topmost element, and top will be pointing to that. And now, what about the fourth? No, 1, 2, 3, 4, 5, fifth figure. After we pop out this 3, where do you think top will be pointing to? Yeah, it's pretty simple, right? Top points to the topmost element. We have 2 operations. We push onto a stack and we can pop out of it. There's also one more operation called peek that actually lets you see the topmost element on the stack without popping it out. Just like to print it onto the screen or display it, whatever. I'll come into that later. And now in this session, I'll be using arrays to implement stack. Arrays was taken in the last session by Pranoy, if I remember. So if you remember, if you have an array of size 5, its indices will go from 0 to 4. That is, if the size is n, the indices will be from 0 to n. So this is how the stack would look. Initially, there won't be any elements here. No 10, no 20, no 30, just nothing will be empty. When you add the first element, it will go to index 0. Second one will go to index 1. The third one will go to index 2 and so on. Okay, so I'll put a link in chat of a website. It'll actually show you how this works. Give me a second. One sec. I move this. So can you guys see the new screen right now? If you can, just put something in chat. Yeah, okay. So here you can see we have an array of size 30. The index goes from 0 to 29. So here we can, if you want to add, say 100 onto the stack, you write 100 and you press push. So what happens is 100 is added. Now, if you want to add 200, say you type in 200 and you press push and gets added. Similarly, you can keep adding elements till we reach the end of the stack. And for popping, if you press pop, you can see that the topmost element will get deleted. The topmost here is actually the rightmost element. I can pop the last one also. Yeah, so that was just for a demonstration, nothing else. Okay, now I'll show you. Okay, in the first session, Vishruth had covered algorithms and algorithms, right? So I'll be showing you the algorithm for all these functions: push, pop, and peek function. This is just a pseudo code, not the proper code. So this is how it works. First, we check. This is the push functions algorithm. Okay. First, we'll check if the stack is full. Assuming the stack is not full, we increment the top pointer. So before that, I forgot to tell you, when you implement stack in C++, will be the top will be an integer type, and it will store the index of the topmost element. So wait, I'll show. See, in this case, topmost element is 30. So top will be storing the index value of that, which will be 2. If the topmost element was 20, top will be storing 1. When there are no elements, the stack top will be initialized to -1. So yeah, first we'll check if the stack is full or not. I'll show how we check that when I actually live code the program. So we'll check if it is full. If it is not full, we will increment the value of top. So here, if top was 2, we'll increment it to 3. Then we'll say stack of top equal to x. X is the value that we are pushing onto the stack. Now there's another condition. Assume we have a stack of size 10. We already have 10 elements inside it. And if we're trying to push the 11th element, it means that we're trying to push an element into an already full stack. That condition is called stack overflow. Just remember that. This is stack overflow. And there's a figure here of pushing an element onto a stack. That's just the stack part. Now we have the pop operation. For pop, we do the opposite. We check if the stack is empty. Because if the stack is already empty, we have nothing to pop. And if the stack is not empty, popping is done by decreasing the top pointer. So say top is here, 30 is the topmost element. Popping out 30 would mean we decrement top from 2 to 1. So that means top would be pointing to 20 instead of 30. And once again, if the stack is empty and we're trying to pop, that condition is called stack underflow. So if you guys have any doubts still here, you can put in chat. If it's clear, you can say clear or whatever. Yeah, I think we'll this is one last function, that is the peek function. So peek function is very simple. We just check if the stack is not empty. If it is not empty, we will print stack of top. That means we'll just be printing the topmost element onto the screen, nothing else. Very simple function. So I hope these 3 functions are clear: push, pop, and peek. We'll do a few output questions with these 3 functions before I do the live coding. Okay, so this is the question. I've got a few functions here, And I want you guys to put the output in chat. If you guys do know, it doesn't matter if it's wrong. Just give it a try. So what this function does is it's pushing 10 onto the stack. This will push 20 onto the stack, and this is peak and pop. Yeah. It's not 10, it's 20 and 10. Oh yeah, you wrote it separately. Okay, fine. Yeah, it'll be 20 and 10. Pretty simple question. I'll have two more like these. What about this one? Now this is a new stack, keep in mind. It's different from the previous question stack. We have a fresh stack here. Yeah. First stack underflow will be printed onto the screen because we're trying to pop from an already empty stack. So stack underflow will come first, then first we'll push 20, then 10 and 30 onto the stack. We'll pop 30 out, and when we do peak, 10 will be the answer. Yeah, you're correct. Okay, so one last one like this. There's one line here also. Yeah, it will be stack overflow and 10. What happens here is first 1000 is pushed onto the stack, then 12, then 10. At this point, 3 elements are already there in the stack. The stack cannot accommodate anymore, so it won't be able to push 40. So stack overflow will be print. And when you peak, the topmost element will be 10, not 40, since it has not been pushed. So I hope you guys are clear here. Now I'll live code how to implement a stack in C++ right now. So anyone here, how many people here are not at all familiar with C++ and C? Okay, so quite a lot of people. Okay, what I'll do is, as I code, I'll be coding in C++. So I'll try and explain what each line of code does. I won't be able to, teach the whole C++ right now. So I'll try to explain it as best as possible. And if you have a doubt, put it in chat. I'll try to clear it. So I'll be using a website called OnlineGDB. I'll put the link here, so if you guys can code along with me if you want. If you want, you can code along with me, or you guys can watch, but I highly recommend coding it at least once by yourself. So if you guys are ready, can I start? Okay. So when you open OnlineGDB, there'll be a small tab here. Select C++ from that. You get a small code already written here. Can you erase the C out hello world part? Yeah. So first, if you remember, we'll start with the push function. So this part here is the return type of the function. What void means is that this function won't be returning anything. This x is the value that we'll be pushing into the stack. Before that, I'll be declaring the stack as a global variable here. So this is the array that we'll be using to implement stack. We declare it as a global variable so that we don't have to pass it to every function every single time. Top is the top pointer that I talked about. Initially, it'll be set to -1. We'll increment it when we add elements to the stack. Size, I've just declared it as 10. It means that the size of the stack is 10. Just a random number I just chose right now. Okay, so before we do the push function, let me show you this. In the algorithm, we saw that we're checking if stack not full or not. We're checking if the stack is full or not. In order to do that, we'll be writing a function called is full. Bool means Boolean. That means it returns a Boolean value that is either it'll return either true or false. So can you guys try and comment in chat when would the stack become full? We have a variable called size here. We have top also here. So using these two, how would you check if the stack is full? You guys can try commenting. So when we add an element to the stack, top will be incrementing. Max size of the stack is 10. Yeah, when top equal to 9. So more specifically, size -1. Yeah. So that's what we'll be checking here. If top equal to means we're checking if top is equal to size -1, we'll return true. True as in the stack is full. Else we'll return false. Okay, and we have one more function similar to this, that is empty. We're checking if the stack is empty. So what would be the condition for that? We'll be using top for checking. Yeah, so top equal to -1. So we return two functions, one to check if the stack is full, that is full, and one is empty to check if the stack is empty or not. Now we'll actually do the push function. First, we'll check if the stack, in order to push onto the stack, we have to check if it is full or not. So we'll be using if the is full function for that. So what this means is that is full will either return true or false. So if the stack is full, it will return true. So we'll add an exclamation. Exclamation mark means it negates whatever this returns. So if it returns true, it becomes false. If it returns false, it becomes true. So here, assume that the stack is not full. So then we'll be returning false. So this exclamation mark will make that true. I think that might be a bit confusing, but just bear with me. So what this if condition will execute only if the stack is not full. Now to add onto a stack, first what we do is we increment the top equal to top +1. Then we say stack of top equal to x. X is the value that we are pushing into the stack. Oh, by the way, if I do make any blunders while I'm coding, you guys can comment in chat. Else is the other condition that we saw, which is stack overflow. That is, we're trying to push onto a stack that is already full. Cout is used to print something onto the screen. And /n will give us a new line after this stack overflow gets printed onto the screen. So that's it for the push function. Pretty small one. Similarly, we have pop also. So what pop does is, first we'll have to check if the stack is empty. Again, similar logic here. If the stack is not empty, we'll be popping from the stack. In order to pop, all we do is we decrement the value of top. So if we just say top equal to top -1, that's it. Else, what we saw before. And we have one last function, that is the peek function. So what this will do is we'll print the topmost element of the stack onto the screen. Again, we have to check if it is empty or not. If I'm going too fast, please put it in the chat. I'll slow down. So we check if it's empty. If it's not empty, we'll print the topmost element onto the screen. We put a /n means new line, just prints a new line after this gets printed out. Else we say stack is empty. So we have 1, 2, 3, 4, 5 functions here. Now the main function will be where we'll use this. Okay, first we'll try and pushing a number onto. We'll say push 10. Oh, first let's see if I have any errors. Yes, I do have errors. Yeah, there is a missing semicolon. Thanks, I didn't see that. Hope that's it. Yeah, okay. So what we did here was we pushed 10 onto the stack and we printed the topmost element. Since there's only one, we'll see 10. We'll add more and see. So I have a code like this. What do you think will be the output right now? You guys can comment. Yeah, 30. Hopefully it is 30. No, never mind. Semicolons. Yeah. So we'll try popping from this. Can you guess what would be the output here? Yeah. It will be underflow plus 30 will also be visible. So you guys clear with the implementation? If you guys have any doubt, you can ask right now. Anywhere in the code. Any of the functions? If you do have a doubt, you can ask. If you guys are clear, can I move on to the next? Clear, okay. Yeah, so I'll move on to the next. Before that, I'll have a few more questions. See, we did 3. Yeah. Okay, so I've got a code snippet here. What means like a small piece of code. So can you guys try and find out what this code does? You guys know that this is a for loop, and this is the modulus operator. What I modulus 2 means is it gives the result. I mean, not result, the remainder when you divide I by 2. In case you didn't know what this operator was. So you guys can just go through this code, take a minute, and comment what this would be. You don't have to print each, type the whole output, just what it would be printing. You can take a minute to go through this. Almost not there yet. I plus plus me. Oh, okay, so I'll just explain for loop in case you guys don't know. So what happens here is I is initially 1. Then we increment I plus plus means we're incrementing the value by 1. So initially it'll be 1, then it'll become 2, then 3, then 4, and so on. It'll go till this condition is met. So that means it'll go till 50. Once it becomes 51, this condition will become false. So it'll exit from the loop. Not exactly. It's not 50. Still not getting it? Okay, so I'll explain what this does. Yeah, so this almost correct. Print the even numbers from 50 to, yeah, to 50 to 2. That is, first what happens is I goes from 1 to 50. What this does is it checks if I is an even number, because an even number divided by 2 will give the remainder 0 always. So if I is even, it will push it onto the stack. So the stack will have 2, 4, 6, 8 till 50. Then what it does is, this is also this is called a while loop, in case you didn't know. It will run until the stack is empty. First, what it does is it will print the topmost element, then pop it out. So what happens is it will print 50, then pop it out, then 48, then pop it out, and so on till 2. So what this code does is it will print the even numbers from 1 to 50 in the reverse order. Do you guys get that? Or should I explain it once more? Yeah, okay, that's clear to most people, I guess. So I got a few more questions like this. We'll see how it goes. It's pretty similar. It's similar to the last one. Just try it. You guys can take a minute to read the code. Also might be a little confusing in case. Just take your time. Oh, sorry. Yeah, everyone's correct. Stack will be empty. We won't even be adding 10 actually. Not even one. I'll tell you the answer is this, the stack will be empty. So what happens here is I will go from 1 till 20. That's what this loop does. And then this is first if condition. It checks if I is less than or equal to 10. If it is, then we'll push I into the stack. So when I becomes 1, it'll be pushed onto the stack. 2 will be pushed, and so on till 10, it keeps getting pushed onto the stack. So when I is 10, there are currently 10 elements in the stack. Then I will become 11. Once it becomes 11, only this else condition will execute. So what happens is it'll from 11 till 20, it'll keep popping. So that is the first 1 to 10 elements that are already in stack will get popped out. So right now here, this loop won't even execute because the stack is already empty. Yeah, print the value from 1 to 10 after. Actually, it won't even print from 1 to 10 because at this once this for loop is finished, all the values in the stack would have already been popped out. See, printing only happens here in this peak operation. So there'll be nothing left to print. You guys okay with that? If you need me to explain once more, I will. Okay, once more, okay, I'll explain it. So what happened? Okay, here, so first loop, I will start iterating here from 1, and it goes till 20. Plus I means it increments. So I initially starts at 1, and it checks this first if condition. If I is less than or equal to 10, since I is 1, it is correct. So it will push I into the stack. So 1 will get pushed into the stack. This process will repeat for 2, 3, 4, 5, 6, 7, 8, 9, and 10. The same thing happens. That is, it gets pushed into the stack. So after when I is equal to 10, there are currently 10 elements in the stack, 1 to 10. Then I will become 11. Once I becomes 11, this if condition will become false because 11 is greater than 10. So it would execute this else part, that is pop. So it will pop out the topmost element. So for 11, 12, 13, and so on till 20, this else will keep getting executed. That is, this else will execute 10 times. So there are already 10 elements in the stack, and since pop gets executed 10 times, it'll pop all the 10 elements out. Then we'll check if the stack is not empty. This while loop will only run if the stack is not empty. But since all the elements have already been popped out, the stack will be empty. So there'll be nothing left to print out. Okay, I hope it's clear. Okay, what about this one? This is similar to the last one, but I think it'll be easier. You guys can take your time. Yes, it does print from 10 to 1, but or else it prints something before that. Sorry. Yeah, that's right. It'll print 10 Stack Overflows. And then it'll print from 10 to 1. No, it won't be printing underflow. It's the other way around. First, it'll print 10 Stack Overflows, then it'll print from 10 to 1. So I'll explain that. So here, there's a line here that says max size of the stack is 10. That means the stack can only have 10 elements at max. Here, just like the last question, I will go from 1 to 20. And it just simply pushes I into the stack. So for the first 10 elements, it's fine. 1 will get pushed, 2 will get pushed, till 10 will get pushed onto the stack. So once 10 has been pushed, the stack already has 10 elements. So it has reached its limit. So we cannot push any more elements. So when we say push of 11, it'll actually print Stack Overflow. For 12 also it'll print Stack Overflow. Like that will print 10 times till 20. And here, what we saw before, it just prints it. We print it, then we pop it out. So we'll go from 10 to 1. Is that okay? Okay. So, okay, I'll show you a piece of code here. Not this one. This has a few mistakes in it. Can you guys find out what the mistakes are? This is just the pseudocode, not the actual code. Just some logical errors. This is the push function we saw earlier, and this is the pop function. You can go through it and see that there's like, I think around 1 or 2 errors. You guys can try and find out what those are. No, forget about the semicolons. This is just pseudocode. Semicolons don't matter. It's just logical errors. Yeah, top equal to top -1 for pop. Yeah, and top equal to, if I didn't add the top equal to top +1 for the push. It's 2 small errors. Yeah, nice. Yeah, that's about it for this. And one more error question. Yeah, the last question, I think everyone got it. No, this is one last error question. Yeah, push should be Stack Overflow. I have here in the push functions written Stack Underflow. And pop, yeah, pretty simple, easy ones. Okay, so I've got last two questions, don't worry. This might be a bit hard compared to the last ones. I'll explain what you have to do. So here you guys can see a stack, and you guys can see the output also here. So remember the push and pop functions. So using those push and pop functions, you need to get this output, and the final state of the stack should be this. That is, after a certain series of push, pop, and peek functions, this is what would be printed on the screen. That is AAC. And this is how the stack would look at the end. So what you guys should try and do is try to see the order of the push, pop, and peek functions. Might be a little confusing at first. Do you guys understand the question? Push A, peak, peak, push B, push C, peak. Yeah, DJ is correct. Push A. Yeah, I think people have got the hang of this. Push A, peak. Push B. Yeah, there's only one push B, not two. Okay, this is the final question here. If you guys can get this, it will be pretty nice. Last and final question. Size of stack is 3. This is how the stack should look at the end, and this is the output. Yep, John Reese is correct. I think you guys have got this. Wait. So the correct answer is this one, push 40, then we push 30, then we peak, then we push 10, then we peak, then we pop the 10 out, then we push 20 and we peak. So then we would get this output and this stack at the end. So yeah, we've come to the end of the output questions. That's it. So you guys clear till here? You guys have any doubts, you can ask in chat. So can I continue on to the next one? Okay. Now we have the last bit of theory left, applications of stack. So here I won't be going into too much detail. I'll just be mentioning it. I don't want to confuse you guys even more. There's a lot of applications, and teaching them all of them right now will take a lot of time. So first is depth first search. This is data structure called graph. I think Pranoy would have covered that in his session last class. So for traversing a graph, we would use an algorithm called depth first search. And this depth first search will use stack. Then there is the undo redo operations that we can find in our Word. Any editor. You make a mistake, you can always press Control Z to undo whatever you did. That uses stack. Then in browsers, there's a back button and a forward button. This also uses stack. It basically keeps a stack of the previous URLs. Let's just go back. Then there is computer memory management. This also uses stack. And this backtracking. Backtracking is a type of algorithm. I won't get into too much detail about that. That uses stack as well. Then there is infix to postfix and prefix conversion. I'll show you what an infix expression looks like. So an expression that is of this form, A operator B. This operator can be, say, plus or minus or divided by whatever. So any expression that is of this form, A operator B, is called an infix expression. Postfix would be A, B, and operator. So that means the operator would come after the operands. So operator can be plus, minus, whatever. Similarly, prefix would be something like this. This is what an infix, postfix, and prefix expressions are. So yeah, to convert an infix expression to postfix or prefix, we would be using stack. Then for evaluating a postfix expression also, we'll be using stack. I don't think we'll have time to cover all of that right now. So I'll just, I've just given you a brief idea. So there'll be a document shared at the end with resources. So there'll be some links there. You guys can visit those to find out more about these topics in detail. Now we have come to the last part. So right now we have two people here. This guy is called Santosh, and this is Sridharan. So they're in college. You guys know what happens in college. Teacher gives an assignment. Everyone goes to the smartest guy in class. After he finishes, takes his assignment, submits it. So the teacher is pretty sick of that. So what she decided to do was give every single person individual assignments. So Santosh has got his own individual assignment, and Sridharan also. Both of them are pretty lazy. They don't want to do it. So they come to you for help. You, being the nice person you are, decide to help them out. So we'll see the assignments that Santosh and Sridharan have got, and we'll hopefully help them. So yeah, Santosh was given a relatively easy assignment. Santosh was given an assignment to reverse a string. Write a program to help him reverse a given string using stack data structure. So if you have an input like this, CUBU, your output would be the reversed version, OBUC. So can you guys think of a way to do this? And if you can, put it in chat, doesn't matter if it's wrong. Just try, think about it. Try to see if you can. You need to use stack to, get this done. You guys are still here, you can try. Give you a minute. No ideas? No. Don't think of it as using those functions right now. So, okay, what we can do is, this is a string. You can get individual characters out of those. Wait, yes. Okay, max capacity of stack equal to 4. Yeah, what John Rhys said is correct. You don't have to, okay, it's fine even if you put max capacity of stack as 4. This is okay, I forgot to tell you, since a stack, till now we added integers onto a stack. We can also add characters, strings, whatever. It depends on how you define the array. It's not just integers. So what John Rhys said is correct. First, you will push each individual letter from the word onto a stack. So we'll start at the beginning. So we'll be pushing C, then U, then B, then O into a stack. Then we'll like peek and pop it out. I'll write and show it to you, make it more clear. So initially you have the word CUBO, Cubo. Reduce the size. Okay, now this will be your stack. Initially there's nothing inside. First you'll add the word. We'll start it from the beginning of the string. So we'll be adding C first. So first add C, then we'll go in the same order, U, B, and O. We'll be adding this whole string onto the stack. And then when we pop it, right now, the top of the stack will be O. And this is the bottom of the stack. So top will be pointing here. When we pop it out, we'll be starting from the top of the stack. So when we pop, what comes out first will be O. This gets popped out. Then we'll pop out B. So what happens is, and we'll print it. B will come. Then we'll be popping out U. So after B, you get a U. And there is C. And finally, that also gets popped and printed. So we have like successfully reversed this entire string. Did you guys get that logic? If you do, if it's clear, you can something. If you want me to explain it again, I'll do so. Clear, not clear, anything? Yeah. So I'll show you how to code that in C++ also. Okay, what we'll do is this is the code we've written before for full empty push pop peek. I'll be using that same code here. What I can do is I'll add another function to reverse it. So in C++, there's a data type called string. You can directly use the string data type to store a string. So here, the main function, I can say string A equal to CUBO. And then I will be passing cubo into this function, reverse function. So this is how you would be passing the string into the function. And right now in the function, what you do is first you'll push each of the characters from cubo into the stack. So what I've done here is kind of like a short form. What this means is that I've declared a variable called s, which is of character type. And what this means that s will iterate through the string A. So since A is cubo, what this means is first s will be equal to C, then U, then B, and O. So what this does is s is just iterating over it. So initially s will be C. So what you do is push s. Before that, here we've declared it as a character integer stack. We'll have to make it character. Since we'll be pushing characters into the stack and not integers. So yeah, we pushed, what this will do is it'll push each and every single character of cubo or whatever the string is into the stack here. So once it has pushed it, we'll pop it out while the string is not empty. I mean, a stack is not empty. What we did here is empty. We'll check if it's not empty. So we'll have to make a small modification here. Here we are like simply printing the top element, but I'll change this to return stack of top. This will have to be changed to the character, whatever it returns, since stack is a character type. Be character of peak. So what this means is that this stack of top, when we call the peak function, this topmost element will be returned. So let's declare a string called answer. Right now, answer is an empty string. And we'll first initially we'll append so what this does is we are appending this topmost element of the stack onto this string called answer. Initially it's empty. First we'll take a look at what the topmost element is, add it onto this string, then we'll pop it out. This process keeps getting repeated till all of it gets added to this string called answer. So if I see out answer, I hopefully might get the correct answer. We'll see. It's string answer, right? Yeah, it is string answer. I've declared it as a string here. So after I declare it as a string, I can just use it as answer, ANSW. See right now, so I'll try another word. Computer. You get the reversed version. Whatever you try, you'll get the reversed version. Yeah. Okay. So the first session for DS4 Not 4 was about time complexity in algorithms. So if you guys, can you guys try and guess, not guess, try to find out what the time complexity is for this one? Just give it a try. Doesn't matter if you're right. Anyone? Yeah, it is O of M. Since we are iterating here from first will be if say the name was Hugo, n will be 4. So we iterate from 0 to 1 to 4. That is, this loop will happen 4 times. This will also be happening 4 times. So we have 2 into n. Since for time complexity we won't consider the constant part, we'll say it's O of n. Yeah, that's it. And that's we've come to. You guys understood this question? You guys need any further explanation for reversing a string? You guys can put in chat if it's clear. So with that, we have helped. Let me see. Yeah, we have helped Santosh do his assignment. Now we have one last person left. That would be Sridharan. Oh yeah, this is the algorithm, what we just did right now. We push each character into the stack. We pop from the stack and add it to the new string. We display the string. Now this is the last problem for the session. This will be coming to the end. Just have to help Sridharan. This will be a slightly harder problem. A little bit confusing. We'll just see anyway. Sridharan was given an assignment. Given a balanced expression that can contain opening and closing parentheses, check if it contains any duplicate parentheses or not. Write a program to help them solve it. So see the input here, the first input. A duplicate, this is what a duplicate parenthesis looks like. X plus y has one parenthesis surrounding it, and another additional one that has no other purpose. This is what you would call a duplicate parenthesis. Here again, Z has one parenthesis, then one more surrounding it that would be, useless. That serves no purpose, so it would be called a duplicate parenthesis. Here, there would be no duplicate parenthesis since there's just one. You guys got what this duplicate parenthesis means? If you guys did not get, please do put it in chat. Yeah, for this one, for the one that Kevin just put, x plus y plus z, there would be no duplicate parentheses. If this parenthesis thing is not clear, just do put in chat. I'll explain once more. One sec. So you guys want to try and guess try to find out the algorithm, or should I explain it on how to do this? Then if no one's getting it, shall I explain it? Oh, okay, coming. So searching for two of them would not work. I'll show you. I'll show you an example. One sec. I didn't quite get what Anu said. What are you pushing? Push, pop, and peak. Okay, before that, let me just show what John said. So here, there is no duplicate parentheses right now. But so we cannot search for this particular characters in order like this. If you search for it here, the program would output that there is duplicate parentheses. But here there are no duplicate parentheses since these last two are covering the whole, the expression as a whole. So do you get that, John? Why you won't be able to search for two opening parentheses and two closing parentheses? So yeah, this might be a little confusing. So I'll try and explain the algorithm. Okay, so what you have to do is you have to iterate over the expression first. And then we will check if the current character is an opening bracket or not. If it is not an opening bracket, we push it onto the stack. And this else is if we do encounter an opening bracket. when we do encounter an opening bracket, this is what we check first. We will check if stack of top is a closing bracket. If it is, that means we return true. That means it is a duplicate bracket. I'll show you how that works with an example. Assuming the stack of top is not a closing bracket, we will keep popping till this closing bracket is found. And if this condition is never met, it means that there are no duplicate parentheses. Okay, I'll make it clearer with an example. So we'll give the example, take an example here. So this is an example that is given to us. So based on the algorithm, first you have to iterate over this string. This will be given as a string, so we'll iterate over it. And first when we iterate, the first character we get will be this opening parenthesis. And based on the algorithm, we'll be checking if it is a closing parenthesis or not. Since it's not, we'll be pushing it into the stack. So this is what the stack will look like initially. Opening parenthesis. Let's move this here. Then we'll go to the next one. Same thing. We push the next one also into the stack. Then x is also not a closing parenthesis. We push. Similarly, we'll keep pushing on to stack till we reach y. Once we reach y, the next character is a closing parenthesis. So according to the algorithm, we have reached a closing parenthesis. So we have to check this condition. If stack of top is equal to an opening parenthesis. Okay, I'm just going to say bracket. Saying parenthesis is pretty hard. So we'll check stack of top. Stack of top right now is y. So this 3.1 condition is false. So we'll go to the else. In the else, what it does is we keep popping from the stack till we find an opening bracket. So what we'll do is we'll pop from the stack. First we'll pop y, then the plus, then x, and then we have reached an opening bracket. So that's what here we say pop till opening bracket is found. And we'll pop that also. I think I forgot to add that here. Yeah, we have to pop that also. So then that means step 3.2 is complete. Then we'll continue iterating. So right now we were over here on this bracket. Now we'll go to the next one. We find an closing bracket again. So we'll see this condition. If current character is not, since it is a closing bracket, we'll check this. If stack of top is opening bracket or not. This is the only thing remaining in the stack. This opening bracket. So what happens is this condition becomes true. Then that would mean that we have to return true. That would mean that this bracket we just got right now, along with the current one we are on, would be a duplicate one. Do you guys get that? I think it's pretty confusing. Just if you guys don't get it, it's fine. Just put it in chat. You guys have a basic idea. Well, right now we are, let's see if you have to. Actually, yeah, it's fine even if you, actually you do have to push. See, assuming you don't push x plus y, this x plus y. Consider this example. You would push this and assume you don't push anything other than the brackets. So right now you have your stack would be, yeah, one bracket like this. And once you reach, let's see, this bracket, you'll be checking this condition, this 3.1, if stack of top is opening bracket. That condition will be true. So then that would mean we will return true. True as in it is a duplicate parenthesis. So that's why we this condition only is this 3.1 condition only becomes true if there is a duplicate parenthesis. So if you're not pushing the rest of the characters inside, this algorithm will be wrong. We'll have to do it in some other way. this condition will need, I mean, it's necessary for this condition that we push the other operators and the operands, not just the brackets. So what about everyone else? Is it slightly okay? If it's not clear, it's fine. You guys can put in chat. You guys are still here. It was a pretty long session, pretty tiring also. We've almost reached the end, don't worry. I guess. Can I continue or should I explain it once more? Once more, okay, yeah. Yeah, we have a few people saying once more, so I'll just do that again. I'll use another example this time to explain the algorithm. Take this one. So the expression is x plus y. So according to the algorithm, we have to iterate over this expression. Can you take, okay, I'll take the example x. So first I'll push this opening bracket into the stack. So the stack will become this. Then I'll push the next opening bracket. And then we'll reach x, we'll push x also here. Then we'll reach the first closing bracket. So what happens is, according to the algorithm, we'll check this first. If stack of top is opening bracket. Before we pop, we'll be checking before we pop. So right now stack of top is x, not a closing bracket. So this 3.1, this condition here will be false. So what we'll do is we'll go to the else part. What the else part does is keeps popping from the stack till we reach a closing, I mean opening parenthesis bracket. So according to the else, first we'll pop out x, then we'll, instantly when we pop out x, we'll reach opening bracket. So we'll stop there and we'll pop out that one also. So here, right now we are in this character and we've popped out everything till here. Now when we go to the next character, it's another closing bracket again. So again, it's a closing bracket. So we have to check this condition here. If stack of top is opening bracket. Here we can see that there's only one element and stack of top is an opening bracket. So that would mean this first 3.1, this condition becomes true. And this condition only be true if there is a duplicate bracket in the expression. So right now, the outer bracket or the inner one can be considered as a duplicate one. Do you understand the example? I mean, the algorithm for this one, for just x? No, okay, I forgot to say, when we do this question, we are going to assume that the string that we are given is valid. So valid string would mean that the number of opening brackets and the number of closing brackets will be equal. There's actually a different question for this, where you check if the brackets are, matching. It might be a bit too difficult to do that here right now. So I've tried to take this easier version of that. So we're going to assume that the input given to us will have balanced number of strings. I mean, brackets. That is, the number of opening brackets will be equal to the number of closing brackets. Here in this example, there are 3 opening brackets and only 2 closing brackets. I forgot to mention that. My bad. Really sorry. Is there any other example you would want me to try? It's fine. I can just, can you take an example where the, oh yeah, I was starting that, then I got sidetracked. 1 second. X plus y. Yeah, this is simple string. Here right now, there are no duplicate brackets, just one here. So what would happen is, like before, according to the algorithm, we'll push the first string onto the, first character onto the stack. Then we'll push X. Then we'll push X. Then the operator, then Y. Then we'll be reaching this opening bracket. So again, according to the algorithm, we'll check if stack of top is an opening bracket. Right now, stack of top is Y, which is not an opening bracket. So this condition here is false. So we'll do the else part. The else part is we pop from the stack till we reach closing bracket. So we pop Y, we pop the plus, we pop X, and we reach the opening bracket. And after this, we have to pop this one also. So right now we've iterated from the beginning till the end. Until now, we didn't get this condition of stack of top equal to opening bracket. That would mean that we can return false. False as in no. False as in no duplicate parenthesis present. So is the example without a false bracket clear? Can I show you guys the code part of it also? Hope it's clear. Might be a little confusing anyway. Let's show you the C++ code part also. I'll be using the same one here. We've already declared all the functions. I'll just change this function. Change the maybe I'll change the name to. So what are we doing right now? We're checking. I'll change the name to check. I'll give the expression here. Instead of void, it'll be a keep it as void. Okay, so according to the algorithm, first we'll need to iterate over the string, the expression that we given. So like we did in the previous example, we'll do the same thing with the for loop. C A. This means, like I said before, we have a character. We're declaring a character called C, and it will iterate over the string A. So what is C will initially be this bracket, and in the next iteration it will become the next character, and so on. So first we'll have to check if C not equal to, let's see, according to the algorithm, we'll be checking for closing brackets. We'll check if C is not equal to a closing bracket. If it is not, we have to push it into the stack. Push C into the stack. Assuming we reach this else means that C is equal to a closing bracket. That is here. We'll have to do this step 3.1 and step 3.2. So according to step 3. So according to step 3.1, we will check if stack of top is equal to opening bracket. So we have the peek function here. So we say if peek equal to opening bracket. You have to enclose the brackets in single quotes. It shows that it's a character. If it is, like we said, we'll say array not return. Yeah. Will return true. So instead of a void, I'll make this a bool. Bool means boolean. It either returns a true or false. So this return true would mean that it would exit out of this whole function and the control will go back to main. So I don't actually have to put an else here. I can directly start with the rest of the code. The rest of the code is this else part. So what this means, you have to pop till the opening bracket is found. So while not is empty, what we did before, we keep doing the while loop will continue as long as the stack is not empty. So what we do is we have to pop one more condition. Oh, actually, you don't need. While peak not equal to opening brackets. So this while loop will keep running until the topmost element becomes this opening brackets. So yeah, and then we have to pop. What happens is we keep popping till we reach this. And once we reach an opening bracket, we'll exit out of this while loop. But this opening bracket will be still inside the stack. So in order to pop that out, we use an extra pop here. Okay, so like I said before, if this expression contains, yeah. So this expression contains a closing bracket. It will at some point it will get part of this condition, and then true will be returned. So assume you reach the end of the string. That would mean that there are no duplicate parentheses. So you can return false. In the main, you can do an if condition to check if it's true or false. If it returns true, we'll be printing. Else we print duplicates not found. That should be it. I hope there are no, okay, we'll see if there are any mistakes. Return false. Yeah, so it's working fine. So, but here there's a duplicate bracket. So that's why it said duplicate found. So if you remove these duplicate brackets, it'll say duplicate not found. Duplicate not found. One last example we can see here. Yeah, there's a duplicate. So you guys clear with the program? That's pretty much it for the program. The code will be shared, don't worry. If we take away the assumption. Yeah, that would be fine. Number of openings greater than number of closings. Stack. Yeah, so that would mean that having an extra bracket would be considered as a duplicate, right? If it is, then yeah, it's fine. Yeah, then it's fine. This code will work. Nice. So yeah, so it's pretty much the end. That we've helped both Santosh and Sridhar complete their assignments and get marks. Oh yeah, the small part left. I just wanna say. So right now when we wrote the code, we sat and wrote the push, pop, peek, is empty, and around 5 functions just to implement stack. So C++ has a library called standard template library. So within this, we have a lot of predefined data structures, functions, algorithms, etc. That is, these functions, like for the stack, the push, pop, peek, all these functions are already defined within C++. You don't have to sit and write them all over again. So this, I won't be taking much of STL. I mean, I won't be taking pretty much anything else about STL here. I've just given an intro here. In the resources that we'll be sharing, I linked a video, YouTube playlist to STL. You guys can watch that if you want to know more about this. STL is a must if you want to get more into competitive coding. So don't forget to check that out. That's pretty much it for this session, I guess. Yeah. With that, the last slide. That's it. So thank you guys for bearing with me for over 1 hour. I mean, 1.5 hours. How long was it? If you guys have anything to say, you can put it in chat. Otherwise, we come to the end.
Hi there. Am I audible?
Yeah.
Okay. I think that officially brings us to the end of our third session. Oh, didn't notice time pass. So Gautam has put in here. Gautam has put in the effort and all of this and made over these many slides so that you guys can understand this concept, and he's taken time apart. So first of all, thank you, Gautam. And if you want to appreciate Gautam right now, spam the chat right away for patiently sitting. And
no, I have to appreciate the audience for bearing with me for so long. Thank you guys. Especially those people who are actually giving me responses. Thanks a lot.
Oh, that's nice. Yes.
And the guys and the people who weren't, doesn't matter.
Live chats, live responsive chats are the best thing in the world.
True.
Yeah. So thank you, Gautam. So remember that this session is also recorded for the participants out here, and we'll soon be adding it to the playlist. The playlist is also being sent via mail. There is also a test after the session, so do stay hooked on for that. Oh, 1 second. The link for that is currently under works. So is it fixed? Can someone? Yeah, I will. In the meanwhile, I'll share some links here. At the same time, don't forget to join the TLE Discord server. As I remember the certificate, so do register for the session. Okay. And here I'm putting a few links, which are the resources of today's session. We have the source code from all the sessions. It's all in the GitHub repo. And today's test. So mark that, look at that message. It's there, all of it's there. So test yourself on this. If you want to revise, go and check out the recording. The next session, the fourth session of DSA, will be happening tomorrow. We will have Pranav from TLE taking the session. And I believe the topic is about queues. So do join us tomorrow as well. Do stay tuned. Oh yeah, the TLE Discord server link. Oh yeah, it will shortly. In a moment, someone's gonna put it here. Can I have someone from the TLE team put that link up here in the chat? Yeah. Yeah, so as I was saying, tomorrow's DS404's second session. And that about covers our main topics. We will have future sessions from TLE, TMS, and TEC because we have covered data structure so far, and we need to cover algorithms, right? So we will have future sessions upcoming. So do stay tuned for that. Do stay tuned to the mail threads. Yeah, there you go. The chair of TLE MEC has put the Discord server link, so do join in. And with about that, I think I can properly wind it up. So do try the test out. With that, thank you for coming. Thank you for joining. You can leave the meet now. How long will the text be active? Can I get an answer on that from the core team? Till tomorrow midnight. There you go. All right. Thank you for bearing with us for an hour and 40 minutes and actively participating in Gautam's session. Again, thank you, Gautam. Thank you, participants. You may all leave now.